Alright, today we're going to be going over binomial and multinomial expansion. So first we're going to go over binomial expansion, which is if you have two terms in between brackets to the power of something that's not 1 or 0. So we have a plus b to the power of n will be equal to the sum as I starts at 0 and I will go all the way to equaling n of a being to the power of what I is and b being to the power of what n minus I is. And this works because due to multiplication being commutative, it can be written as a to the I and b to the n minus I, where I goes from 0 to n, and we'll know what the expansion is due to the number of i's for the a and the number of n minus i's for the b. Also, before we get fully into the questions, something good to know will be the Pascal's triangle. What this is it's a triangle with all number ones on the side, and you can see we get more terms the farther we go. And if you want to set it up, you start off with 1, 1, 1, and then you're going to add inwards. So it'll be 1, 2, 1. But this one will be 1, 3, 3, 1 because the 2 and the 1 will create the 3's, and the 1's will always stay 1 because there's nothing to add them with. So let's say we have this question here, which is 2x minus 3y squared all to the power of 5. The first thing we're going to do, we're going to label what we have. So our 2x is going to be our a, and our 3y squared is going to be our b. Now, what we're going to do is we're going to start off as having our a having all 5 values of our exponent and our b having 0 values, which will give us 2 to the power of 5 and x to the power of 5 multiplied by all of this to the power of 0, which gives us 1. Now, since we're looking for the sum, that means we have to add, and it will be 5 because of the Pascal's triangle. Because we're going to the power of 5, we need to go 1, 2, 3, 4, 5, because we're on our 5th exponent. So it's going to be 5, and then it's going to be a large bracket to keep it separated, and we're going to have it as 2 to the power of 4 this time, and x to the power of 4, multiplied by 3 to the power of 1, and y to the power of 2, because it's already at 2. And now it's going to be plus again. And if you look at our Pascal's triangle, the next thing for this row is going to be a 10. So we're going to have 10 multiplied by, this time will be 2 to the power of 3. And x to the power of 3 multiplied by 3 to the power of 2. And y squared to the power of 2. And if we keep going, we'll end up just reversing what we already did. So, which means that instead of our 2x having the 3's and our 3 squared and the y squared having the 2's, it's going to become 2 squared x squared multiplied by 3 cubed and y squared cubed. You're going to multiply it by 10 in the front because of the Pascal's triangle again. And we're going to add 5 multiplied by 2 to the 1 times x to the 1 multiplied by 3 to the 4 and y squared to the 4. And finally, ending it off, we're going to have plus 1 times, and this time our values of 2x will have 0, so that'll just be 1 multiplied by 3 to the 5, and then y squared to the 5. Now, if you want to know the full expansion of this binomial, all you have to do is clean it up a little bit, and then you'll get your final answer. Alright, now we're going to go over the multinomial expansion. So multinomial expansion is anything more than 2 variables. So here we'll have 3, but I could go infinitely higher. So it's going to be a number of variables all to the power of n, which again just isn't 1 because otherwise that's not an expansion. That's just the variables you have. And now this is the sum of I, j, and k equaling 0, where I plus j plus k will equal up to n. And this will be done by n factorial divided by I factorial, multiplied by j factorial, multiplied by k factorial, multiplied by the I, b, and c, all to the power of I, j, and k. Or if you want to think of it as n factorial over I factorial, j factorial, and k factorial as the combination of n over I, j, and k. We're going to go over two different ways to write this equation, starting off with just a basic one. So with this one, we're going to follow kind of the same steps as we did for the binomial. We'll start off with our a cubed, so our a gets all three of our exponents, but our b and c get 0. But this time we're going to have our b get all 3 and our a get 0, and then this one will be our c getting all 3. Now what we're going to do is we have to do all the different combinations of having our a, b, and c, all their exponents adding up to 3. So we're going to have 3a squared b plus 3ab squared plus 3ac squared plus 3b squared c plus 3b c squared, and finally we're going to have plus 6a b c. Now this is a general equation that you could follow if you have it to the power of 3, but that's obviously not what we're going to have, and that's not what our questions are going to look like all the time. So instead we're going to try a different way. We're going to have our equation of 1 plus 2x minus 3x squared all to the power of 5, and what we're going to look for here is we're going to look for the coefficient following x to the power of 4. So what this means is instead of having to write the entire equation out, we're just looking for whatever number, such as this 3 or this 6 or this 6, will be in front of our equation when we have our x as to the power of 4. But there's a couple different ways that we could look at it, because we do have an x value here and an x squared here. So what we need to do is we need to have it so that our x and our x squared will use our coefficient to the 5 to get us 4. So here we're going to just look over a couple ways that we can do that. So this will be our x and this will be our x squared. So one way we could do this is having our x squared going to 0 and our x getting 4 added to it, which means that our first variable, which is just going to be our 1, is going to get 1. Now next up we're going to have our x getting 2 added to it, while our 3 is going to get, our x squared is going to get 1 added to it, meaning our 1 gets 2. Finally, our last one is where x squared is going to get 2. Our x is going to get 0, and which means our 1 is going to have 3. Now, these are all going to add up to x to the 4. So for this one, our x is going to be x to the 4. This one, we're going to have x squared plus x squared, which gives us x to the 4. And this one is x squared squared, so this is going to be x to the 4. So now that we got that rough work out of the way, and we know all the different ways that we could get to x4, we're going to write it out in using our formula. So the first thing we're going to do is we're going to have our bracket, and we're going to need our n. So our n is going to be our exponent, so that's going to be 5. And now we need our I, j, and k, which you can see as these. So this will be our I, that will be our j, and that will be our k, meaning we'll have 1, 4, and 0. And now we need to have our a to the power of I, b to the power of j, and c to the power of k. 1 to the power of 1 multiplied by 2 to the power of 4, and then 3 to the power of 0 is just 1, so that doesn't matter. And again, since it's sum, we need to add. And we're going to add our next section, which is 5, and then we're going to have our I, which will be our 2, our j, which will be 2, and our k, which is 1. And now this is going to be multiplied by our 1 to the power of 2, multiplied by 2 to the power of 2, multiplied by negative 3 to the power of 1. And then finally, we need to have our plus 5 and 3, 0, and 2. And this will be multiplied by 1 to the power of 3, multiplied by negative 3 to the power of 2. Now, if you put this all together, you should get negative 190, which means that our coefficient, when we're looking for x to the power of 4, is going to be negative 190. Alright, now we're going to go over how to calculate this right here, our 5140 from our last question. So what this means is we're going to have 5 choose 1, multiplied by, we're going to take the 1 away, 4, choose 4. So our other one would be 5, 2, 2, and 1 from our last question. This will follow the same steps. We'll have 5, choose 2, multiplied. Now we get rid of the 5 and we subtract 2 from it. So there'll be 3, choose 2. And then finally, we're going to have 1, choose 1. All right, now we're going to do 2 examples. One with just the x variable and then one with the y variable, but to much larger exponents. So this one, we're going to look for the coefficient of x to the power of 4. So what we're going to do is we're going to, on the side here, go over all the different ways that we could get all of these to add up to x to the power of 4, just like we did on the last question. So we're going to have our 3, we're going to have our x, we're going to have our x squared, and our x cubed. We're not too worried about the 3, it's just going to be there to help us with counting. So the first way that we could get to x4 is by having our x be 4, meaning that our x squared and x cubed will be 0, which will give us our 3, the remaining 12, because it still has to add up to 16. Now we're going to have our second way, which is our x squared being counted 2 times, which will be 2 times 2, giving us 4. So that'll be 0, 0, but this time our 3 will get 14 of the exponents numbers. Our next way that we could do it is have 1, 1 and 1, 3, which will give us 4, which again gives us 14 for the column of the 3. And our last way that we could do it is by having 2 x's and 1 x squared, giving us 13 for the 3 column. So now to write it out, all we need to do is the same steps as the last question. We're going to have 16 at the top because that's our total value of our n, and then all we have to do is write down our numbers right here, giving us 12, 4, 0, and 0. And now we multiply it by the coefficient in front of all the variables multiplied by the numbers that we gave them before. So this will be 3 to the power of 12 multiplied by 2 to the power of 4. And now we will add, because we're looking for the total sum, which will give us 16. Our next one is 14, 0, 2, and 0. So we can write down 14, 0, 2, 0. And we're going to multiply by our coefficients, which will be 3 to the power of 14 multiplied by, this one will be -1, -1 to the power of 2. And now we have 2 more, so we're going to add, and it's going to be 16 again, because that will never change. And then it'll be 14, 1, 0, 1, multiplied by 3 to the 14, multiplied by 2 to the 1, so that's just 2. And lastly is 4 to the 1, which again is just 4. And now to finish off the question, we're going to end it with 16, and it's going to be 13, 2, 1, and 0. Again, multiplied by the coefficients of 3 to the 13, multiplied by 2 squared, and multiplied by -1. Alright, now our final question is going to be going over trying to find the coefficient where we have an x and a y in the equation. So this one has an x to the power of 2 and a y to the power of 3. So again, just like we've been doing for the past couple of questions, we're going to write a chart out and we're going to try to find as many ways as we can to get to our x squared y to the power of 3. Alright, so our first one that we could do is we could have y to the power of 1 and then our x and y to the power of 2, which could give us our y to the 1, our x to the 2, and our y now being at the 3. And our x would have to be a 0 here, and to make sure that it adds up to 7, our 4 needs to be to the power of 4. Now our next way we could do it is by having x to the power of 1, our y to the power of 2, and our x and y to the power of 1, leaving our 4 to be to the power of 3. And now our final way is for our x to be to the power of 2, and our y to be to the power of 3, leaving that to the power of 0, and our 4 being to the power of 2. Now all we have to do is write it out and even though there's an x and a y, it doesn't change the steps that we had previously. We still write our exponent at the top, and then we're going to just write out all three of these. So we're going to have our 4, 0, 1, and 2 multiplied by 4 to the power of 4, multiplied by 3 to the power of 1, and multiplied by negative 2 to the power of 2. And now we'll add 7 at the top, and this one will be 3, 1, 2, 1, multiplied by 4 to the power of 3, multiplied by negative 1, and multiplied by 3 to the power of 2. And then we're going to add our last one, which is 7 over 2, 2, 3, and 0. And that will be multiplied by 4 to the power of 2. And that will be, and then multiplied by negative 1 to the power of 2. And finally, 3 to the power of 3.